Swayam Prabha. Digital India. Educated India.
Welcome to this course on transition metal organometallics in catalysis and biology. In this series of lecture, of late we are discussing oligomerization of alkenes and alkynes topic, and in that we have discussed about 4 kinds of oligomerization reaction, starting with ethylene oligomerization, and these we have discussed with regard to shell higher olefin process or the shop process, which uses a nickel catalyst for carrying out this ethylene oligomerization. The main drawback, even though this is a industrial scale process, the main drawback is that it is not selective, in the sense that it produces a broad range of distributions of ethylene oligomers of various chain length. This shop is an industrial process that includes ethylene oligomerization along with olefin isomerization and olefin metathesis. Together they constitute the process of shop, which is shell higher olefin process. Subsequently, we have also discussed another interesting reaction, which is ethylene trimerization, and this is done very selectively, in which ethylene is trimerized to give 1-hexene 1-hexanes, and this is a process that use early transition metal tantalum 3 catalyst for carrying out this 1-hexene trimerization. The subsequent that we have also discussed another topic, which is dimerization of propene dimerization, and these produces hexenes of different substitutions, and these branched hexenes, when hydrogenated, give a high quality petrol of very high anti-knocking attributes, and this also uses a nickel catalyst for carrying out such kind of transformation. Now, with these being discussed today, we are going to proceed further, and then we are going to discuss another interesting reaction, which is cyclotrimerization of butadiene. Or maybe we can call it for the sake of butadiene's cyclotrimerization. And this produces cyclooctadodecatriene. Cyclododecatriene, and uses also nickel catalyst. Now, if one were to look, we are going to be discussing about this topic in as a part of today's class. Now, in this connection, it is worth noting that if one were to look at all these oligomerization process, for example, oligomerization, trimerization, dimerization, cyclotimerization, all of this process, then one would see that the metal of choice for such a process is in fact nickel, which is a late transition metal. And also supposedly very electron rich. Now, this is a interesting observation as well as correlation that comes out of this oligomerization reactions. So, what it says that olefin oligomerization is usually favored by electron rich late transition metals, whereas olefin polymerization is favored by early transition metal, electron deficient early transition metals. So, this is a conventional wisdom in the area of olefin oligomerization and polymerization. Now, from this perspective, this ethylene trimerization with tantalum 3, which is an early transition metal, sort of stands out in the sense that there are some examples of even lower order of lower degree of polymerization like trimerization happening with electron deficient metal like tantalum. But note that the oxidation state of tantalum is not 5 and 3. So, hence it is not really very electron deficient as it would have been if it were in the plus 5 oxidation state. Now, with that we are going to focus on today's discussion, which would be centered around this butadiene cyclotrimerization reaction and look at various ways that they form. One thing to note that in terms of application, before I proceed further, in terms of application, these SWAP is applied for were applied for preparing detergent ingredients application in detergents industry, whereas this propene dimerization giving hexanes, branch hexanes, these are in automobile, because they are used for producing petrol of high quality anti knocking agents. So, this is application in auto industry. The auto industry, and this ethylene trimerization is providing very selective 1-hexenes. They are also used for commercial purpose. Also to note that this particular reaction, which is propene dimerization, having applications in high quality petrol of anti knocking capacity, the activity of these catalyst is extremely high, the turnover number, and it is quite comparable to that of a biological enzyme like catalase that carry out these kind of transformations. So, having said that, so here we have a system which is extremely efficient and has a very high turnover number with respect to similar to that or comparable to that of an enzyme catalyzed reaction. So, from that perspective, this catalyst or this process is quite remarkable feat that demonstrate the capability of organometallic catalysis in the world of chemical transformation. Now, with that discussion, let us move on to this topic of today's discussion, which is cyclotrimerization of butadiene. So, what we are going to primarily focus on is the mechanism in which how it works. So, the precursor is a nickel to allyl complex, bis allyl complex, that is the catalyst precursor, and the oxidation state over here is nickel 2. Now, that in presence of butadiene, undergoes reactive elimination. Of the 2 allyl moiety to give a diallyl compound as is shown here. So, the reactive elimination happens between this and this, resulting in diallyl compound as is shown over here. And it gives this nickel 0 species with 2 butadiene. So, the oxidation state for this species is nickel 0. Now, that subsequently reacts with butadiene to give the species which is shown over here. Now, this is the oxidative addition reaction of 2 butadiene moiety to form this bis allyl ligand, and the oxidation state of the nickel has become nickel 2 as a result of this oxidative addition reaction. Now, this is in equilibrium with this species, which is a sigma bond and this is a pi bond, which are now separated, and at a very low temperature greater than minus 40 degree centigrade, this the second insertion happens onto this ligand, giving rise to this nickel 2 species, which also is nickel 2, and then this is an important species which subsequently trimerizes at reaction above minus 40 degree centigrade to give the corresponding nickel 0. So, this is a sort of reductive elimination process to give the nickel 0 species, as is shown here. And this is called naked nickel. And this is a nickel 0 species which finally eliminates the butadiene trimer to give this cyclic trimer. This is called trans 159 cyclododeca triene. This gives cyclododeca triene, and this butadiene, two of them then enters the catalytic cycle. So, this is a interesting mechanism which has been proposed by Wilke, in 1960, and this involves the formation of nickel, as is shown over here. So, this involves formation of nickel as is shown over here. So, the main feature is the transformation from nickel 2 into of the catalytic cycle, as well as nickel 0 or the naked nickel in the 2 of the catalytic cycle. The other important thing is that these particular species was confirmed by preparing it separately and entering the catalytic cycle through this species, which also gave the identical cyclotrimerized product. So, this is indeed a very good reaction that has been successfully carried out, in which butadiene can be trimerized to give trans 159 cyclododeca triene, as is shown over here. So, the key features of these cyclotrimerization reaction is given below. key features the number 1, the precatalyst is a bis allyl complex is complex of nickel. Then the second thing is the mechanism was validated by independently preparing one of the intermediate and then successfully entering the catalytic cycle. So, another important attribute of this mechanism is the change for the metal for nickel, change in coordination number from 3 to 4 and the oxidation state zero to 2 are observed, and the last but a very important attribute is naked nickel in nickel 0 stabilized by donor ligands are observed. So, these are the key attributes of this cyclotrimerization process, which sort of shows the feasibility of this nice reaction through the through the metal undergoing flexible displaying flexible coordination mode by changing the coordination number from 3 to 4, as well as flexible oxidation state by changing the oxidation state from 0 to 2. In the process, naked nickel stabilized by alkene donors are formed, and they are part of the catalytic cycle. Lastly, the catalytic cycle is even validated by entering the catalytic cycle through one of the catalytic intermediates which were prepared independently. Now, having said this, even though this was a very nice and beautiful reaction in terms of the applications of organometallic catalysis are concerned. However, this reaction is not being used in industrial scale for producing this cyclododecatrine or trimer of butadiene, and this cyclododecatrine in industry is prepared by Ziegler-Natta process, as is shown over here. Cyclotrimerization of butadiene in industrial scale. process use Ziegler-Natta catalysis, and this is shown below. 3-butadiene with titanium tetrachloride R2L2Cl3 and this gives this cis trans 159 cyclododeca triene that is further hydrogenated and then finally in presence of oxygen and the second with nitric acid is this acid is produced in large scale about 10,000 ton per year annually. Even though this Wilke's method of producing butadiene trimerization is a very nice beautiful method, but this is not being used in industry probably because of difficulty in handling the air sensitive nature of nickel 0 intermediate that is produced in the process of cyclotrimerization of butadiene, and hence a Ziegler-Natta catalysis are used to produce this trans cyclobutadiene, then which is then hydrogenated and subsequent oxidation and nitric acid produces this diacid about 10,000 tons annually in a large industrial scale. So, with this I come to the conclusion of today's lecture. In today's lecture we have looked into cyclotrimerization of butadiene in the context of various other topics we are covering along the theme of olefin and alkyne oligomerization reaction. We have looked into the mechanism as proposed by Wilke using a nickel catalyst, and then we have also looked at the alternative pathway which is used in industry using Ziegler-Natta catalyst using titanium tetrachloride to produce the cyclotrimerization of butadiene in large scale processes for making a diacid in about bulk quantity about 10,000 tons annually. So, with this I come to the conclusion again one more time to of today's lecture, and I look forward to taking up the topic in bit more detail. Little bit remains on this olefin and alkyne oligomerization reaction, and subsequently we will take up olefin polymerization reaction as we meet next. Till then, goodbye and thank you.